Hi, this is Sophie. I'm just going to shift my face so it's underneath the recorder. Okay, so I did this meme saying I'd talk or maybe record a video about any topic I was given, and I was given the topic of maths by Kent's Arrow, which on the one hand is a topic I have a lot of opinions about, on the other hand it's such a huge topic I was like, oh god, what do I say? So I'm just going to say whatever pops into my head. So what to say about maths? For a start, maths is great. It's much cooler than people think. I really enjoyed it. That's my cat, Kira. She doesn't like maths so much. A PhD in maths, that must mean like adding numbers all the time, right? Well, no, that wasn't what I was doing. And B, I'm not actually very good at addition or subtraction or multiplication. I used to be good at them back when I was a kid, unless it involved time. You give me, you know, the difference between 2:30 in the afternoon on Tuesday and 4:15 in the morning on Wednesday, and I have no idea. And time zones baffle me. I don't know why. But other kinds of addition I used to be good at, and then I got older and it all got smooshed out. So what did it get smooshed out by? For me, algebra. I absolutely adore algebra. The idea of getting beyond concrete numbers or objects and dealing with kind of an abstracted idea of an object or a number or a quantity and dealing with those. And my favourite kind of algebra is the abstract algebra. Group theory is what I ended up doing my PhD in. And that's when you come up with these theories and facts that are true about a whole range of different kinds of things. And you can just plug them into your proof. So you can prove something and it's true for say, binary numbers, 0 and 1. And it goes 0, 0 plus 1 is 1, 1 plus 1 is 0, 0 plus 1 is 1, and so on and so forth. And that's the binary numbers, and then you've got, 0, 1, 2, 0, 1, 2, etc., which is, I'm not sure what that's called, but base 3, and so on. And then you've got rotations, right? And so if you've got an object, let's use this remote control, right? An arbitrary object. And then you go, okay, so 0 is going to be leaving the object alone, and 1 turning it over. So 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 0. And so the rotation around 180 degrees is mathematically equivalent to the numbers 0 and 1 in binary. Hey, so I thought I was done. This is an extra section I'm going to add in the middle because I got the maths wrong. So I guess that just goes to show that getting numbers right and having a good mathematical brain are not necessarily the same thing. So here is the example of rotations equivalent to 0, 1, and 2 and base 3. So here we have an arbitrary object, which you'll notice is different to the previous arbitrary object, and it's still mathematically equivalent. I could even use my water bottle, but this is smaller. And we're going to define 3 rotations. This is 0 degrees, which is 0. This is 120 degrees, which is 1. And this is 240 degrees, which is 2. And you notice that if you add 120 to 240, you get 360, which is the same as 0. And so you go. So our rules are 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 0. And then you can go, okay, so 2 plus 2 is 1. And if you count your fingers, you go 0, 1, 2, plus 1 is 0, plus 1 again is 1. So 2 plus 2 equals 1 in base 3. And so the maths of rotations by 120 or 240 degrees, the same as the maths of 0, 1 and 2 in base 3. Now I have those numbers right. Before I was saying it was 60 degrees, which is a totally different angle. Hooray for me not being very good at geometry. And you can take that up to higher levels, and so you can deal with a whole bunch of different kinds of stuff without having to really deal with the actual stuff. So if you're someone like me who forgets what number a rotation by a third of a circle is, but you understand the kind of abstract idea of doing something 3 times and you end up where you start, then this kind of mathematics really appeals. And it kind of feels like you're understanding the basic structure of the universe. I mean, I used to study theoretical physics. I used to want to be a theoretical physicist. My dream was to be like Stephen Hawking, only not in a wheelchair. That turned out well. I got the wrong side of that bargain. I'm in a wheelchair. I don't know much about theoretical physics. Anyway, but it turned out that theoretical physics to me was too real world. There was too much emphasis on like solving Mackey equations with rough terms where you what's the word? It's a disgusting word. They do it in engineering and they don't do it in pure mathematics, and so I never do it. Estimate things, yes. Estimating things makes my skin burn. And there was this point in physics in second year where they said, so the equation sine looks a lot like the equation x around 0, because x looks like this and then goes like that, and sine looks like this and then goes like that. So everywhere we see a sine, which is a complicated equation, we'll just replace it by an x. And I thought, but you haven't said when. You're just going to replace all the sines, and for like sine infinity, or sine a million is about 1 or 0. Well, infinity is infinity, a million is a million. And so you're saying a million is roughly equal to 1 sometimes? No, that makes no sense. Why are you doing this? It's not right. I want exact values. I want perfection. I want the spheres of the universe in this constant, beautiful pattern. And so I quit physics and went into pure mathematics and never learnt anything useful again. Well, that's not true. My thesis is used by other mathematicians, and those mathematicians then make theories that are used by more practical mathematicians, which are then used by physicists, which are then used by engineers, which are then used by actual people in the real world doing useful stuff. So, maybe in 100 years or so, the stuff that I discovered will be useful to someone in a practical sense, but it makes me happy. This is also why I went into teaching, because I wanted to share the theory with everyone, and then I discovered that other people weren't as excited about maths as I was, and when I tried to get the 6-year-olds excited about the 4-colour theorem, it didn't turn out so well, and I quit that job too. Anyway, this isn't about my career as a mathematician, how it didn't turn out very well. This is about how maths is great. Maths is a lot of fun, and I'm not one of these evangelical people who thinks that everyone should love maths. If you don't love it, that's fine. I don't love geography. I've tried maps, just baffle me. I don't understand them. And I have friends who love geography, and that's good for them, those guys. But I can understand that they don't hate it the way I do. It obviously makes them happy, and that's fine. It's like we're in different fandoms, I'm not gonna geography shame them. Okay. I'm going to just add a little bit more at the end because I descended into incoherence before. So what I want to say, like that I don't think I really got across before, let's see if I can say it now. Basically, I don't like the fact that it's assumed that the only way basically, either you're good at maths, in which case you're probably using it to make lots of money, haha, not necessarily, and are really, really smart at everything and just generally smart, and then you can enjoy it. Or you're stupid and you should just hate yourself and hate the subject and force yourself to learn it because you need it to make money, but it's not actually fun. And I think that's just ridiculous. I think maths is a tool. I think there's different kinds of thinking, different kinds of training make you better or worse at certain kinds of mathematics, and there isn't just one kind of mathematical thinking. There's certain kinds of maths I'm really not that good at, certainly by comparison. And there's certain kinds of maths, some people are just, like, I know people who are just amazing at adding things up in their head. My mum failed high school maths, well, didn't do very well in high school maths, but she can add up like a whiz, and she really enjoys that, and I think that's fine. I don't think she should feel ashamed and go, oh, I'm terrible at maths, so I'm not allowed to enjoy it at all. I think if you I think people should be encouraged to enjoy it in the same way that people should be encouraged to enjoy sport, even if they suck at it. You know, I suck at sport, and obviously now I suck at, you know, walking. But when I was younger, I wish that I'd been taught to enjoy just the sheer physicality of playing games and stuff, even if I was terrible. And I think even if you're not as good as the average, if you're not as good as you'd like to be at maths, you should still be able to enjoy it. You should still be able to enjoy the stuff you do without feeling self-conscious about not knowing everything, not being good enough. There's no good enough. You know, there's one of the things I learned during my PhD is I'd been smarter than everyone at maths most of my life, or at least, you know, near the top, and then there were all these people who were smarter than me. I was nothing. That's what doing a PhD is all about, is destroying your self-esteem. And it took me quite a while to realise it didn't matter, you know, and I draw, I'm not the world's best artist, but I enjoy it, and I think maths should be like that. It's a tool, and it's fun, and if you enjoy doing puzzles or whatever, good for you. And it shouldn't be, yeah, we should just be taught to enjoy it, and to use it when we need it, and if you need a bit of help, there's no shame in that. We all need help sometimes, and you shouldn't be made to feel like a bad person, is basically my little ex-maths tutor rant. Yeah, so, yeah, and I wish we could all love maths to the extent that we need it and want to do it. So, yay maths. That's my moral. Okay, bye.